Okay, this is the second part of our global warming lecture. Now we're going to look at the evidence for and the consequences of global warming. So what kind of evidence do we see? And most importantly, how does the evidence fit together? So sometimes skeptics will point to one specific data point and call it into question, but what I want you to be able to do is, if someone asks you, give several different kinds of evidence for the overall picture of what's happening and show folks or be able to explain how those things are connected. And then we'll look at some of the possibilities going forward. Okay, so first of all, it's clear that there is an increase in global temperatures. So this includes both the surface temperature on land and water, and it's comparing it to an average of this whole time. So you can see that we used to have lower temperatures, the temperatures are getting higher, and there's this trend towards increasing temperatures. So from year to year there can be some variation, but overall, given this long record, we can be pretty confident that temperature is going up. Second, sea level is rising, and you can look at over roughly the same time period, sea level in terms of millimeters. We're starting out here at zero change, and then it's picking up. And interestingly enough, some people are arguing that the rate at which it's changing is increasing. So not only is it going up, but it's going up at a steeper clip. In other words, we're like picking up speed. Key point here is that the numerous points of evidence converge. We should expect global average surface temperatures going up. That's what we see. Sea level should be going up. That's what we see. In northern hemisphere, snow cover should be going down. That's what we see. Fourth point, the models are accurate. So in other words, when they have these computer simulations and they plug in a bunch of different data points, and here are several of the different different models, and they plot them, they're able to both explain temperature changes in the past and explain temperature changes in the future. And so this here is a certain data point, 2015. So during this period between, 2012 and 2014, it looked like the models were not being accurate, and that they were overall over-predicting the temperature wasn't going up as quickly as they had predicted. But with this 2015 data point, it's again back on that track. And so the short story is the models do predict accurately, within some error, that what the temperatures are going to be and what they've been. All right, fifth point here is the vegetation is shifting north. So stuff that didn't used to grow at a certain latitude is now growing at that latitude. So if you look here, there's certain bands that now stretch farther up. So that means the reason those bands are shifting is it's getting warmer at any given latitude. So plants that used to have to be a little bit closer to the equator can now get by being a little further away from the equator. You also see the same phenomenon or similar phenomenon in that vegetation is shifting higher. So trees might have stopped at a certain point, but now that as you move up in altitude, temperature goes down. If the temperature is increasing, they can start creeping up and up to higher altitudes. Point 6, there's more extreme weather events. So somehow I missed the date here. Looks like it's, but the website is 2014. So it's the change in heavy precipitation. So you can look in all these different regions in the U.S. We've seen more and more cases where there's storms that bring a ton of moisture. And if you look at the trends over time, going from the 1900s up to the 2000s, again, we see this clear increase in terms of these heavy precipitation events. So these can be heavy thunderstorms, heavy snowfalls, heavy hurricanes. So ironically, when it snows a lot in the winter, there's some skeptics that'll say, "Ha! That shows there's no global warming." In actuality, that is exactly what's predicted, that you're going to get more, because of the warmer air, you're going to get more precipitation events. Point 7, the glaciers are retreating. So I think this is at Glacier National Park. I'd have to double check that. But you see some folks here, and there's a cave. And then, wow, by 1988, it's all gone. This is in Alaska, the Muir Glacier. It's there. And then now all this area has retreated until it's only back up in there. The Alps, we started off with a slide from the Alps. Here's another one. There was all this huge glacier here, and now that's all disappeared. This is another one. I think this is in Alaska. I'm not positive. Here's Mount Hood. This is in Washington. You can see lots of snow, and then not so much snow. Okay, point 8, you're having, this is still melting, but now we're talking about what's going on at the poles. So if the Antarctic ice shelves are melting. So the way the Antarctic works, there's land here, but then there's these ice sheets that extend out over the water, and some of them are beginning to melt and break off. So I'll show you, here's the Larsen B ice shelf. I'll show you that in more detail. So here's in January, and then in March, this is where the ice shelf was, and then what you can see here is all this area broke away, and it's roughly the size of Rhode Island. So in other words, these are huge chunks of ice that have broken off and will break off. You can also see melting in the North Pole. So in the pole, the North Pole, it expands and shrinks. The ice cap does, depending on the time of year. Obviously, in the winter, it's going to be more expanded. In the summer, it's going to shrink back. But the extent to which it's shrinking back is getting more and more pronounced. So this was the boundary of the ice in the summer in 1979, but you can see it's gone in a lot past that. So here's another way of looking at it. This is the extent of the Arctic sea ice in 1984, and here's what it was in 2012. Here's another figure that shows you where it was in 1980. That's the red area, and then the pink area is where it was in 1998 and 2012. And so obviously the big problem here is the North Pole is where Santa Claus is, and that's where all your presents come from. So you can look forward to some depressing Christmases. But in actuality, one of the depressing things is that it's having a huge impact on the species that live there. So polar bears are drowning. They're finding it harder and harder to find food. They'll flow out. Their fishing strategy is to swim out to these different ice flows, but now they'll swim out there and they won't find anything, and so they're more likely to drown. Some other bizarre things that are happening: the fabled Northwest Passage that different explorers had searched for to try to get up around North America, those passages now exist. So in the summer, you can navigate from Finland and Sweden over here to the United States. It's a much quicker route, obviously, because you're just going across the top. It's not covering as many miles. And so that's having a number of commercial implications. Another point is that, ironically, because we have burned so much oil and gas, we are making more oil and gas available for harvesting in the Arctic because we have melted off some of the ice caps that were had before covered up those deposits and prevented access. Some more melting stuff. Greenland, which crosses into the Arctic, is experiencing a similar thing where in the summers you get more and more ice melt. So this is a neat 3D graph here where you can see the 92 melt line is significantly lower than the 2005 melt line. So what you see from year to year is more and more of the snow melting each summer. And you can see this pattern in the trend line there going up to 2008. And here's a graphical quantification of what's going on. So I have the yellow line pointing here to the average, which is the dotted blue line. And you can see in some recent years it's gotten pretty extreme. So 2012 was a particularly extreme year where you had a huge amount of ice melting, and then some other years. But you can see overall they're on this side of the average, meaning that there's definitely a trend in the direction of more melting in the summers. It is a dynamic system. In other words, you're talking not only about how much runoff there is, that's the blue line, but also how much accumulation there is. So because there's more snowfall, because the air is getting warmer, some of that ice is replaced by more ice that falls, but in general, you can see that there is a growing gap where these two things used to be in concert. Now you have more runoff and ice discharge than you do accumulation, and that means you're in danger of having these ice slip away. So here's how this might happen. So you have these moulins that develop, which are holes in the surface of the glacier that where water that's warmer melts the tunnel down to the bedrock, and then this can act like a lubricant and allow this whole ice sheet to slide. Okay, so some of the evidence we have here: rising temperature. I think there was a mistake on your slide where I had the second one labeled as rising ocean temperatures. It should say rising sea levels. Third, there's the evidence converging for the models are predicting accurately. So the computer models are accurate both going backwards and forwards. Vegetation is shifting, weather events becoming more extreme, glaciers are retreating, the Arctic and the Antarctic are melting, and Greenland melting. So if nothing else, grasp that it's a very consistent story with a lot of different characters all pointing in the same direction of substantial changes to our climate and Earth systems. So the future, what's likely to happen moving forward, and what are the consequences? Well, all predictions include warming. It depends on what assumptions you make, but it's clear that in any case, we're going to have, at the best case scenario, a little bit of warming. At the worst case scenario, enough that it could be catastrophic. And I'm going to try here to go to a website that the NASA has. Let me see if I can get this shrunk down for you. If we go here to the global temperatures, you can see that there is this schematic where I can start in 1884, and as I drag it to the right, we can see what happens to the temperature differences, and you'll see that it gets steadily warmer and warmer and warmer. I'm up to 1983, 1993, 2000. It's looking crazy, and then it even gets darker and darker. So this is suggesting that many dark red areas are hitting 2 degrees Celsius change from over the last century. Okay, and sea levels are expected to continue to rise. Again, there's different projections. We don't know what's going to happen exactly, but we do know it's going to increase. And depending on the scenarios, there could be enough sea level rise that you would lose whole areas of Florida. And bear in mind, there are millions of people that live here in this area, and that's so we can have a 3-meter rise would knock out that much, a 6-meter rise would knock out that much. So as you might surmise, people like being near the ocean, and so some of these areas that would be inundated would be some of those closest to the water and most populated. Okay, worldwide, it's going to put 10 to 50 million at risk because, like I was just saying, there's a lot of people that live in these island nations and live, say, on the coast of India, the coast of China, Japan. It's just mind-boggling to think about what that would be like. Bangladesh is an area that's low-lying. It's right to the right or the east of India. Many millions of poor folks live here and would have hardly any place to go. And then some other possibilities: if the whole Greenland ice sheet falls into the ocean, that could dramatically change the temperature and the convection patterns that we have. And if you have ever thought about it, Canada is very cold, and Canada is about at the same latitude as Europe. What keeps Europe warm is the Gulf Stream, which brings up warm air and water from the Gulf of Mexico. And this could all be disrupted if you had a huge inundation of ice from Greenland or elsewhere. So other consequences, and these are all substantial. Water supplies will dry up because you'll have drier climates. You'll have ecosystems wither where species can't adapt fast enough, have mass extinctions. Food production will be hugely disrupted. So if you think about all the areas where you're growing corn and wheat with irrigation, as the water disappears, you're going to have a harder time producing crops. All kinds of health consequences, more diseases are possible. In the coastal areas, loss of wetlands, dogs and cats living together, it will be crazy. So finally, let me introduce some what I call sense-making factors, and this is trying to think about how people think about all these facts and what motivations they might have. So first of all, we have these cosmological beliefs or orientation where depending on one's religious views or philosophical views and the way you think about humanity and who's in charge of the planet, you might have the inclination to believe that some higher power will fix all of this, or you might not. But that will shape whether or not you are inclined to believe some of these data. If you have a static versus a dynamic view of the world, the evolutionary ecological view of the world accepts that things are always changing, but that kind of view is threatening to many folks, and they tend to have a more static orientation. And that, obviously, as just at the beginning of the lecture, varies with political orientation. And we'll talk about this stuff later on. Second, there's the motivation to think about. So who stands to gain or lose psychologically or financially from global warming? So if you think about some of the richest, most powerful corporations in the world are energy companies, specifically oil companies, and they have a direct incentive to not mess with their cash cow. And so they have funded many activities to undermine climate scientists and perpetuate the idea that we are not sure about global warming. There's the cognitive dissonance that many of us experience on an individual level, where we like our cars, we like our big houses, we like eating meat, even though all these things contribute to the problem. So we're inclined to find reasons to doubt global warming so we can keep living the way we're living. If you look at the age and politics of deniers, this is one of those issues the older people get that tend to be more conservative and more inclined to have a hard time accepting that there are major changes. There's also this phenomenon called system justification, where people are inclined to want to believe they live in a fair and just world. And so global warming is challenging that, and is a reason why some people will dismiss it because of their desire to believe that things are fair and just. You can also think about previous industrial pollution phenomenon. So what happened with the antifoliant DDT, what happened with ozone depletion, leaded gasoline, and cigarette smoking. In all these cases, you had industry groups arguing vociferously that there was nothing wrong with their product and that all the science was wrong, only to eventually come out and admit that, yes, there was a problem. And by then, a lot of damage had already been done. Again, one of the things that will affect how we make sense of something is what we stand to gain or lose by that. And especially when you have corporations and all their communication and funding prowess put behind a certain perspective, it can easily trump some quiet, data-loving scientists. there's some other issues in terms of the way science approaches things. Science tends to be very statistically conservative. So that's not politically conservative, but statistically meaning they don't want to claim something's there unless they're absolutely very certain that there is something there. And so they will tend to say things like, we're fairly certain, or there's strong evidence, but they may not use the kind of language that most people find compelling. And then another point is that scientists are not really trained to persuade or advocate. They're kind of trained to engage in this arcane art of carefully presenting data, but there's oftentimes a gap between that and the way the public makes sense of things. And then there's methodological issues. I'm going to jump down here to, first there's this convergence of scientific data. So from a lot of different perspectives and a lot of different methodologies, you can see a very similar story being told. That's something that the skeptics often don't acknowledge. Second, there's been a bias in the way journalists operate, in that with reduced funding and resources, the best they can often do is to report both sides of the story. And so they will say, these people say this and these people say this. And that works great for certain political issues, but science reporting, there's certain positions that have more weight. So it's as if we were talking about whether the Earth was round or flat, and journalists would just report on both points of view and not report that there's vastly more evidence for the idea that the Earth is round. So that is another issue in terms of how the public makes sense of things. And then there's, as we've mentioned, the oil company behavior. The funding, they're at the same time they're funding deniers, they're snatching up Arctic leasing rights to drill for the oil where the ice used to be. So there's some ironic behavior there. Some pragmatic issues to think about. There's the relative consequences of error. So if we decide that there's no such thing as global warming, we're taking a risk. If we say there is global warming, we're taking a risk because we're spending money on it to fix it. As a counterpoint, or an example of how we might approach it, Dick Cheney in the Bush administration had a prevention principle where if there was a 1% chance that a foreign power would be a threat to us, that we needed to take immediate action. So there's certainly more than a 1% chance that global warming will produce vast amounts of pain and suffering, and it should be simply on a precaution principle be enough to instill action, but it may not. Second, there's a delayed impact in terms of the consequence of certain behavior. It may be 50 years, 100 years out, where the carbon that we generate today finally has an impact. So in other words, it's hard to adjust as you go because the consequences of your actions are so delayed. And another issue is that we don't know if there's certain catastrophic tipping points where once temperature, say, hits 2.5 degrees change, that may be enough to melt all of Greenland, which then causes all the ice to come in, which causes a 6-meter rise in ocean levels, which then could trigger other problems. So we are driving very close to the edge of the cliff, and it's not exactly clear where that edge is. Third, we're gambling with unknown variables. We're doing an experiment where we don't know what those parameters are. We don't know where the edge of that cliff is, so it's dangerous.